Guys, this is test 32, game 1. This is the students in the seminar game. This game is, a little bit unusual because we're choosing 6 people out of a total of 8 and then assigning those 6 people to morning or afternoon. So for that reason, this game has a little bit of an in-out component to it, although really the most important part of the game is actually, assignment in nature, assigning the people to the different days. This game does not have that much of an ordering component. It's more about dividing the people into morning or afternoon and then putting them on Monday, Tuesday, and Wednesday. You'll see here that really the only ordering component of the game is this last rule, which I'll explain. I'll explain all of this diagram in a minute. The N rule, the third rule of the game. Anyway, I'll explain the diagram I've done thus far. We have morning and afternoon, and Monday, Tuesday, Wednesday. So I've assigned morning to the top, afternoon to the bottom, because that's what your typical calendar planner probably looks like. Anyway, they tell us that Tuesday is the only day on which George could go. The issue here is that George might not go at all. We could have valid scenarios where George is not selected, where he is not one of the 6 who ends up on these slots. So rather than putting George above the Tuesday column, I've instead said that George is not going Monday and George is not going Wednesday. Next, they tell us neither O nor R can be in the afternoon, so I've put down O and R next to the afternoon with slashes through them because they might go in the morning or they might not be chosen at all. Final rule, the most complicated rule of the game. If N goes, then we have H and I in the following day. So I've written here, and if N goes, conditional rule, N arrow, N followed by HI, where N's in the morning, and then H and I are interchangeable on morning, afternoon, or ends in the afternoon, in which case H and I are interchangeable on morning and afternoon once again. Now this rule does say that is the case unless N is given on Wednesday. That's essentially a loophole closer. They're simply suggesting to us that N could still go on Wednesday. It's just that when N does go on Wednesday, this rule no longer applies, of course, because it would be impossible to meet the necessary condition, given that there is no day following Wednesday, there is no Thursday at all in this game. So they're simply telling us N could still go Wednesday, just when it does, the rule doesn't apply. They don't want us to mistakenly think that this rule should be taken to mean N does not go at all on Wednesday ever. They're still allowing for that possibility here. I've decided not to note that part of the rule just because it would be annoying or difficult to write down. I recommend that you instead try to hold it in your head. If you want to, you could just put down N sub M/T, meaning N subscript Monday/Tuesday, but I don't think it's necessary. I think that's more complicated than the rule really warrants, so I just don't bother writing it down. Anyway, this is our initial setup for the game. Now, number 1 is our typical, list question or orientation question here. We are simply looking to figure out which one of these is a valid scenario. So 4 of these choices violate some rule, one of them does not. I recommend, as I generally do, taking one rule at a time, applying that rule to all 5 choices, looking for violations. So the simplest rule, of course, is that G can never be on Monday or Wednesday. It must be on Tuesday. So if you scan through the rules, you want to look for G occurring on Monday or Wednesday. I see that occurring here in choice E. We have G Wednesday afternoon. G could never be Wednesday. That's unacceptable. So E is eliminated. We also know that neither O nor R could ever be in the afternoon. So scan for choices where that occurs, and you'll see that A has R Monday afternoon, unacceptable. B has O Monday afternoon. That is unacceptable as well. So for that reason, A and B are both eliminated. Now the final rule, the most difficult one regarding N, we know that if N goes on Monday, Tuesday, then we'll have to have H and I both following on the next day. So if you look at the choices here, we have in choice D, N is Monday morning, yet we have only I on the following day. We do not have H on the following day. Instead, H is on the same day as N, unacceptable in this case. So for this reason, D is eliminated and C is our answer for number 1. Next, number 2, if K and L do not give reports, so neither K nor L is going to be selected here, we will instead have G, H, I, N, O, R as our 6 people chosen. So what we can infer from this is that O and R both have to go, yet they cannot go in the afternoon ever, due to the second rule of the game. So for that reason, they will actually go in the morning at some point. So they ask us, what could the morning reports be on Monday, Tuesday, Wednesday, respectively? We need to have both O and R occurring at some point in the morning. Now, if you scan through the choices, you'll see that A doesn't mention O or R at all, unacceptable. B mentions only R, not O, unacceptable. C mentions only O, not R, unacceptable. D mentions both, looking good there. E mentions only R, not O. So D is our answer. The correct listing must include both O and R in the morning, and D is our answer for number 2. Next, number 3, a pair of students who, if they occur in the same day, that day must be Wednesday. So basically, which pairing of people cannot ever go together on Monday or Tuesday, but could go together on Wednesday? So you want to think about, what's unique about the days in particular regarding pairings of variables. Well, the biggest rule, of course, is the third rule. If n is Monday or Tuesday, h and I will be on the following day. So the only day that n and h could ever be together, or n and I could ever be together, is Wednesday. So the correct answer to this question is going to be nh or ni. Choice B has both n and h, so B is our answer for number 3. Next, question number 4. If G and R are all chosen and on different days from each other. So they're all separated. The morning-afternoon aspect is not especially important here, except with regard to R, which will have to go in the morning in this case. So I'm just going to draw things all on the morning level just to make it easy to write down and to follow. So what could be true? Well, we know that G will have to go on Tuesday because G always goes on Tuesday whenever it is selected. N will not be able to go on Monday because if it were, we'd have to have H and I on the following day, the immediately following day, and G being on Tuesday gives us no room for that. So for that reason, N will have to go on Wednesday, and R will have to go on Monday, giving us out a general R, G, N ordering. So now they ask us what could be true. Just run through the choices. H on Wednesday, that certainly seems possible, so we'll keep it for now. It's looking pretty good. B, N on Monday. No, N has to be on Wednesday, so B is eliminated. C, N on Tuesday. No, once again, N is eliminated. N is on Wednesday, not Tuesday, so C is eliminated. D, O on Monday. Well, we already have R on Monday morning, so there is no room to have O on Monday as well, given that O and R both can never be in the afternoon. If they are both chosen, they will have to be in the morning, and they cannot share the same time slot. There's only one person per slot. So for that reason, D is impossible. And then E, R on Wednesday, no R specifically on Monday, leaving A by process of elimination for number 4. Next, number 5. If K is Tuesday afternoon and H is Wednesday afternoon, so we'll put that down, K Tuesday afternoon, H Wednesday afternoon. What could be an accurate list of students on Monday, Tuesday, Wednesday mornings in particular? So we know that N cannot go on Monday at all in this case, because then we'd have to have H and I on Tuesday, and we know that H is on Wednesday already, and there's no room to have both H and I on Tuesday anyway because K is there. So we can now infer that N cannot go Monday afternoon, on Monday at all, I'm sorry. So this Monday afternoon slot right here is looking especially limited because neither G nor N could go on Monday at all, and neither O nor R could go on afternoons at all. So let's think about for a moment, who could go on this most limited slot for Monday afternoon? It cannot be K nor H because they are already assigned to other slots. It cannot be O nor R because they cannot be in the afternoon. Cannot be G nor N because they have to be on Tuesday or Wednesday. If they are chosen, they cannot be on Monday. So really only I and L could go on Monday afternoon. So I'm going to put down I/L in the Monday afternoon slot. So for that reason, we could never have both I and L in the morning. At least one of those two must always be in the afternoon, Monday afternoon in particular. So any choice listing both I and L for the morning has to be eliminated. And if you scan through the choices, A has both I and L, B has both I and L, C has both I and L, D only has I, not both I and L, so that seems pretty good. And then E has both I and L listed as well, so we've got D by elimination for number 5. Next, number 6, if H, K, and L give the 3 morning reports, what must be true? So H, K, and L are specifically being chosen here to be in the morning, so we know that they're going, and we know that they're going in the morning, although we don't know specifically what slots they're going to be in. Now, since neither O nor R could be in the afternoon, if they are chosen, they have to go in the morning. Yet the morning row is already filled by H, K, and L, so we can infer that neither O nor L is being selected at all in this question's scenario, and we will be choosing G, H, I, K, L, and N as our people. Now, H, K, and L are already going in the morning, so we know that G, I, and N will have to go in the afternoon in some ordering. Now, when G is chosen, it's always on Tuesday, so we can infer that G is on Tuesday afternoon in this case. N cannot go on Monday due to the third rule of the game. It would have to have H and I following in some combination on Tuesday, but there's no room for that given that G is here. So for that reason, N will have to go on Wednesday afternoon, and I will have to go on Monday afternoon, giving us I, G, N for Monday, Tuesday, and Wednesday afternoons, respectively. So what must be true? H gives the report on Monday. H could be any of Monday, Tuesday, Wednesday for all we care right now, so A is not necessarily on Monday and eliminated for A, number 6. B, I on Monday. Yes, that is a must. We see that I is Monday afternoon, so B is our answer. I will run through the rest, though. I on Wednesday. No, of course, N is Wednesday. I is on Monday. C is gone. D, K on Tuesday. K could be any of these 3 slots for all we care on the morning level, so D is gone. And E, K on Wednesday. Again, K could be any of these for all we care. E is gone, leaving B by elimination if you didn't get it before.